Okay, 5.2 notes. We're going to be somewhat reviewing chapter 4 stuff from trimester 1. When we ended chapter 4, we talked about transformations. Okay, and in transformations we had rigid motion. With rigid motion holds side lengths, so holds side lengths and angle measures. Okay, with rigid motion, side lengths and angle measures stay the same. So our first question is, of these three, or of these four, which hold rigid motion, or which have rigid motion? Okay. A translation, remember, is just moving things left or right, up or down. Okay, so that one holds rigid motion for sure. So I'm going to circle, yep. A reflection, well, reflection just flips it. Right? Angle measures or side lengths don't change, so that has rigid motion. Rotation just twists it or turns it. Okay? That has rigid motion. Dilation, remember, dilation changes the size. Okay, so the side lengths change. So that does not have rigid motion. Alright? And I talked my way through explaining them. Going down here. It says, describe a composition of rigid motions that map ABC to DEF. So how does ABC map onto DEF, and use transformations to describe that? Okay? So our first one, what it does is it flips over that x-axis. So I'm going to draw my triangle in red. Point B stays the same. Point C falls down here, and point A falls down here. Okay, so our new triangle, B prime, C prime, and A prime, right? And then it shifts 3 units to the right. Oh. So, to describe this, it is a reflection over the x-axis and a translation 3 units to the right. Okay. Part B. Part B is just a 180-degree rotation around the origin. And remember, we can go back to our rotation rules, but 180 degrees from A, B just turns it to negative A, negative B. So if we have -2, 0, or flip that, it's going to be 2, 0, which is at point E. We have 0, 2 at E, 0, 2. If we flip that, we have 0, -2, which is right here. Right, and then we have -2, 3. Nope. -2, 3. We flip that, we got negative. Oh, sorry, we got +2, -3. +2, -3. Okay, so that's just an easy 180-degree rotation. Moving on. Part C. Part C is a 270-degree rotation. Okay, so 270-degree rotation. If you think about our rotation rules, right? So let's start with A at -2, 3. Our rotation rules will put us at 3, 2. right? So at 3, comma 1, 2. If we think about our rotation rules, point B at -2, 0 will be at 0, 2. Yep. So that's B prime. This is A prime. And then C is at 0, 2. That changes and goes to 2, 0. So here is C prime. We're left with this triangle here. And then it's just a translation of 3 units down. So okay, there's our transformations there. And then part D, I'm going to go quickly here. It's just a 270-degree rotation. Followed by a reflection. That's reflection. I know that is terrible handwriting, and I'm sorry. Followed by a reflection over the x-axis. Okay. Oh, sorry, not x-axis. It's the y-axis. My apologies. All right. So there's our transformations of those 4. Those can get difficult. So number 3 says, how can you use rigid motion to map one triangle onto the other? What you can do is look at the orientation and decide which rigid motion will get it there. Okay. Number 4, I'll let you guys do. Okay. What's going on? Corresponding parts is probably the biggest definition in 5.2. Corresponding parts is I'll just draw it. I find images easier. Okay, so if we have 2 triangles, we'll call it A, we'll call it B, we'll say C. And then we have another triangle here. We have D, we have E, we have F. Okay, let's say angle A and angle D are the same. Angle B and angle C are the same. And angle C and angle F are the same. Okay. Not only that, let's say AB is congruent to DE. Let's say BC is congruent to EF, and AC is congruent to DF. The corresponding parts, AB, I'm just going to say same AB, is congruent to DE, right? So each part of that triangle, or those 2 triangles, are congruent. Okay. Angle B, let's say angle B is congruent to which angle? It's angle E. Okay, so the corresponding parts are B and E, or A and D. So in this triangle, let's say this triangle here, my congruent statement here can be triangle ABC is congruent to DEF. Okay? My corresponding parts are my angles, so angle A and angle E, angle B, angle A and angle D, angle B and angle E, and angle C and angle F. For my side lengths, right? Side length AB and DE, those are corresponding. BC and EF, those are corresponding. So it's the same position and the same angle. Okay? Those are corresponding parts. You can read the theorem 5.3. 5.4, third angle theorem. This one says that if two angles of one triangle are congruent to two angles of the other triangle, okay, so in this figure, angle A is congruent to angle D, and angle B is congruent to angle E, well then we have to know, actually we do know, that angle C is congruent to angle F. We know that. Okay? Moving on. In exercises 1 and 2, identify all pairs of congruent corresponding parts. Then write another congruent statement for the polygon. Okay. Well, what do we know about angle P? It is congruent to what? See, this one has 3 marks here. What other angle over here has 3 marks? It's angle S. Okay. Angle Q, it's congruent to, well, this one has 2. What other one has 2? Angle T. And angle R is congruent to angle U. Okay, so write another congruent statement. I'm only erasing this so I can show you something very important. If I write a congruent statement and I say triangle and I start with, let's say, Q, and then let's say RP, QRP. I cannot name that second triangle any way I want. I have to name it in the order I named QRP with its corresponding part. So if I started with Q, I have to start with angle T. Because I started with this angle, I have to start with this angle. Okay, then I went to R. I have to go U over here. Then I have P. I have to go S. So when I name a congruent triangle, I have to name the corresponding parts. Okay, in the same order. Moving on to number 2. You guys can do this one. You guys make sure corresponding parts are matched up. I'm going to scroll on and go down to here. Number 3, find the values of x and y. Okay, well, if we know that x, y, z, so x, y, z is congruent to r, s, t, we know that y and s, angle y and angle s, they're congruent to each other. We know that. That's what they gave us. So we know that 2x minus 20 is equal to 30 degrees. Okay, if I did this, I'd get 2x is equal to 50, and I'd end up with x is equal to 25. Okay. Looking at my figure, I have a dash here and a dash here. So that means those are congruent side lengths, right? Well, YZ is congruent to ST. So these are congruent, right? Those are all congruent sides. So we know that 15 is congruent to 3y plus 9. If I subtract, I get 6 is equal to 3y, and that y is equal to 2. Again, I'm going to let you guys do number 4. It's good practice. I'm going to move on. Next says 5 and 6 show that the polygons are congruent. Okay, that's easy. Well, I know that this 90-degree angle here, I know that this has to be 90 degrees, right? This here is a line. And the angle measure of a line is 180 degrees. Well, I know if this one is 90, ADB is 90 degrees, then BDC has to be 90 degrees, right? So, figured that one out. That's good. Okay. What else do I know? Well, if And I'm just going to color code here. If angle D is congruent to angle D, right? Or ADB is congruent to BDC, and we know that angle A is congruent to angle C. What else do we know? Remember, this is if we know two parts are congruent from the triangles, we know that the third angle has to be congruent. Okay, well, good thing. All right. Now, we have three angles when we only have two sides. We only have two sides. What do we know about this third side here? That third side is equal to itself. Okay, and that might sound simple. It might sound weird to you. But this side, okay, is equal to itself. So, therefore, we know that DA is congruent to DC. And we know that AB is congruent to BC, or CB, sorry. And we know that DB is congruent to DB. We also know that angle A is congruent to angle C. We know that angle ADB is congruent to angle CDB. And we know that angle ABD is congruent to angle CBD. Okay, that's my reasoning. Therefore, the congruent part, or the corresponding parts are congruent. So here's what I'm going to say over here: corresponding parts of both triangles are congruent, therefore they're congruent. Okay, I'll let you guys do number 6. Now move on to number 7. In exercises 7 and 8, find the measure of angle 1. This first one, number 7, looks a little tricky. But look, 1 mark, that's equal to 33. What else has 1 mark? Angle 1. So angle 1 is equal to 33 degrees. Okay. This next one, we know that 54 plus 80 plus u, we'll say u, has to equal 180. Doing this math, we get 134 plus u equals 180. Subtract 134 from 180, and we get 46. U is equal to 46. And angle U is congruent to angle 1, so angle U is congruent to angle 1. Therefore, angle 1 equals 46 degrees. There you go. That's lesson 5.2.